So good morning, everyone. My name is Kevin J. Keenan, and my topic is about evaporation. So evaporation includes all processes by which water returns to the atmosphere as water vapor. So water vapor, it is the gaseous phase of water. So we have the source of evaporation. So first we have evaporation of intercepted rain and snow. So comes from rain and snow. And also we have evaporation from bare soil and water bodies such as ponds, lakes, and streams. And transpiration from plant leaves. We all know that transpiration is the process which soil moisture taken up by vegetation. And then this change in state requires an exchange of approximately 2.5 kilojoules energy for each gram of water evaporated. So we have an illustration here, no? So we have a warm ocean surface, and then we have the sun, which gives off heat energy, no? Well, directly to the ocean. So now evaporation will process through the heat energy from the sun. And then we have evaporation requires the following four conditions, no? We have the four conditions requires of evaporation. So first we have the available water, no? And then second one is higher humidity at the evaporative surface than in the surrounding air. Another example, we have the vapor pressure. And then energy to evaporate the water. So we need an energy, no? For example, the energy came from the sun, which is the heat energy. Then also it requires a movement or transfer of water vapor away from the evaporative surface. And then we have the factors affecting evaporation. First, we have the wind. So when wind speed is high, it assists evaporation. Pag yung speed daw ng hangin, no, is mataas, ina-assist niyo yung evaporation. And then we have the heat. So evaporation is more in summer as compared to winter. So talagang mas ano yung evaporation if summer, no? Because summer is tag-init. Or yeah, and then compared to winter, no? There is no rays of there is no much heat energy, no? So the evaporation is low. And then number 3, exposed surface area. So for instance, a wet cloth spread out dries faster than when folded. So sinasabi dito na yung damit is mas madali siyang madadry if naka-spread siya or nakalatag kaysa yung naka-fold. And then we have number 4, humidity. So dryness assists evaporation. For instance, clothes dry faster in summer than during the monsoon when the air is humid. And then number 5, we have the nature of liquid. So rate of evaporation depends upon the type of liquid, no? For example, yung mga petrol or yung mga gasoline or alcohol or some flammable liquid is evaporates faster than water, no? Than natural water. And then we have also the vapor pressure, no? This is one factor that affecting evaporation. So if pressure is applied on the surface of a liquid, so evaporation is hindered. Yung evaporation daw is something madedelay siya, or there's something obstruction that will happen, no? Consider, for example, the case of a pressure cooker. And then we have the measurement of evaporation. So we have a lysimeter. So a lysimeter is a measuring device which can be used to measure the amount of actual evapotranspiration which is released by plants by recording the amount of precipitation that an area receives and the amount lost through the soil. And we have two types of lysimeter. We have first the non-weighable lysimeter or percolation type. So this lysimeter can be used only for long-term measurements, unless the soil moisture content can be measured by some independent and reliable technique. So large area percolation type lysimeter are used for water budget and evapotranspiration studies of tall, deep-rooting vegetation cover such as yung nature trees. And then we have the second type of lysimeter, which is weighable lysimeters. So these are much more expensive, but their advantage is that we secure reliable and precise estimates of short-term values of evapotranspiration. So provided that the necessary design, operation, and seating precautions have been taken. And then we have the pan evaporation. So pan evaporation is a measurement rather that combines or integrates the effects of several climate elements such as temperature, humidity, rainfall, drought dispersion, solar radiation, and wind. And evaporation is greatest on hot, windy, dry, sunny days. And then it is greatly reduced when clouds block the sun or it is cloudy, and when air is cool, calm, and humid. And then pan evaporation measurements enable farmers and ranchers to understand how much water their crops would need. So through this pan evaporation, farmers or workers are able to measure or understand how much water their crops will need, no? And then there are many types of evaporation pans used by farmers. However, the universal pan is the United States Weather Bureau, or it is USWB. It is a Class A pan evaporimeter. It is important to use the same dimensions such this universal pan, mainly because the effect of wind and temperature on evaporation will vary with the surface area and the depth of water in the pan. And then we have a picture of evaporation pan here, no? Then the evaporation pan of this standard set is made of stainless steel and has the dimensions of a Class A evaporation pan, namely 54 millimeter or 10 inches in height and 1,206 millimeter or 47.5 inches in diameter. And then we have a measuring principle, of a evaporation pan. So an evaporation pan provides a measurement of combined effect of temperature, humidity, wind speed, and sunshine on the reference crop evapotranspiration, or it is sub-zero. So we have the principle of the evaporation pan, no? First, we have the pan is installed in the field. That's very important, no? Kailangan sa field mo talaga siya i-install. Then the pan is filled with a known quantity of water. So the surface area of the pan is known and the water depth is measured. Kailangan naka-measure talaga siya. And then the water is allowed to evaporate during a certain period of time, usually 24 hours. No? For example, each morning at 7 o'clock, a measurement is already taken. So the rainfall, if meron man, no, it is also measured simultaneously. And then after 24 hours, the remaining quantity of water is measured. Another example, it's water depth. So the amount of evaporation per time unit, it is the difference between the two measured water depths. So it is calculated. So this is the pan evaporation, which is a pan in millimeter per 24 hours. And then the E pan is multiplied by a pan coefficient, which is K pan, to obtain the ET sub-zero, or the reference crop evapotranspiration. So we have the formula of ET sub-zero equals K pan times A pan, which is ET sub-zero is reference crop evapotranspiration, and then the K pan is the pan coefficient, and then the E pan is the pan evaporation. If the water depth in the pan drops too much, so due to lack of rain, no, kapag walang rain, so water is added and the water depth is measured before and after, no, the water is added. So if the water level rises too much due to the rain, also water is taken out of the pan and the water depths before and after are also measured. And then we have the determination of K pan. So when using the evaporation pan to estimate the evapotranspiration, so in fact, a comparison is made between the evaporation from the water surface in the pan and the evapotranspiration of the standard grass. So the water in the pan and the grass do not react in exactly the same way to the climate. So therefore, a special coefficient is used, K pan, to relate one to the other. So we have the pan coefficient. K pan depends on, first, the type of pan used. Second, the pan environment. If the pan is placed in a fallow or crop area. And then the climate. So the humidity and the wind speed. And then for class A evaporation pan, the K pan varies between 0.35 and 0.85. Average K pan equals to 0.70. So the K pan is high if the pan is placed in a fallow area. The humidity is high. The wind speed is low. Another example, if humid. And then the K pan is low if the pan is placed in the cropped area. The humidity is low. The wind speed is high. So another example, it is dry. So if the pan factor is not known, the average value could be used. If more accuracy is required, the pan factors can be taken. Groom the table below for class A pan only. So table, pan coefficients, KP for class A pan for different pans sitting in environment and different levels of main relative humidity and wind speed or irrigation and drainage paper. We have a table here. So we just not get focus in this table, no? Because our time is only limited. So I will jump directly here in example, which is type of pan, no? If we have a type of pan, class A evaporation pan. So if we have an example here, if the water depth in pan on day 1 is 150 m, and then water depth in pan on day 2 is equals to 144 m, it is after 24 hours. So if we have rainfall during 24 hours is equals to 0 millimeter. And then we have a K-pan is equal to 0.75. So we all know that we have a formula of ET sub 0 is equals to K-pan times A-pan. First, we need to get the value of A-pan. So we have 150 minus 144, which is equals to 6 millimeter per day. We have already our A-pan, so we can calculate the ET sub 0, which is equals to K-pan, which is 0.75 times 6, which is our A-pan. So we have a result of 4.5 millimeter per day. So lysimeter, experimental methods for measuring evapotranspiration. So one method for measuring evapotranspiration is with a weighing lysimeter. So the weight of a soil column is measured continuously, and the change in storage of water in the soil is modeled by the change in weight. So the change in weight is converted to units of length using the surface area of the weighing lysimeter and the unit weight of water. So evapotranspiration is computed as the change in weight plus rainfall minus percolation, or we have the PA is equals to R plus A minus P. So that's it. Thank you, everyone.